I'm happy to see everyone here. I'll just talk a little bit about my experiences with SPSS and R to start off with, and then we'll dive in. The class will have a lot of hands-on, a lot of time for questions because that's really the best way to learn any new software. I've been using SPSS since 1992, which actually predates the Windows version of the program, and I've been really dedicated SPSS user, but I started to become troubled when it became clear that a lot of my students were having issues accessing it. Many of them were having to illegally download it or to buy it because computer labs weren't available. So about 10 years ago, I spearheaded an effort to move our department's teaching over to R. And one thing that I was really surprised with was how easily students were taking to R, as it is simple. It can be simple. However, there's a lot of resources that you'll find out there that aren't particularly simple, that complicate things. So I will try to bring you my experience as an SPSS user, being immersed in SPSS for years and years and years, and some of the things that I've learned along the way to help me to transition to R. With that, let's get rolling. I'll just share my screen here. And all right, and let me just make sure that the screen is shared. Perfect. All right, so we'll break this up into several different sections. Throughout the different sections, there will be opportunities at the end of several. There will be opportunities at the end of several of the sections to do hands-on exercises. I'm trying to aim for about 40–50% hands-on because that is really the best way to learn the material. I mean, I can talk about R all day, but unless you're jumping in and you're actually working with the material, it probably doesn't. It probably is not going to take as well. So the first thing that we'll start with is I'll introduce the R computing environment. I'll introduce the R computing environment. There we go. One thing I wanted to talk about is some of the different terminology that we have. I think terminology is always a big challenge when moving from one area to another. So with the different terminology, I'll talk about how we talk about things in SPSS and then how we talk about things in R. It gets a little muddled, but just trying to draw links between the two pieces because you will see various resources that use different terms that are going to be that can be a little bit challenging to new users. Okay. So different terminology. SPSS uses terms like data, syntax, output, variable, nominal, ordinal, scale in various places. R uses the same, it has the same definitions, but they use a little bit, R uses a little different different terminology, I should say. In SPSS, we just call our data data. In R, you'll often hear this referred to as a data frame. It's just data. There's really no difference between the two. It's just the terminology piece. SPSS, we talk about syntax. In R, we talk about code. Pretty much the same thing. You have a coding language that you can use to write things. Where R is a little different is it does not have the pull down menus for analyses that SPSS has, which there's positives and negatives to that. With R, you do have to write code to run analyses, and the positive there is that your analyses become more reproducible. It's a lot easier to get back to what you've done than it is when you're doing during pull down menus. However, it is a little more challenging, and it's probably one of the pieces that has the biggest learning curve. In SPSS, we have an output window. In R, it's simply just called the console, and it's not a window that we can really save. So that's something that's a little bit different. You might be used to saving your SPSS output. Here in the R console window, we would need to copy and paste things to Microsoft Word. And in more advanced classes, you can learn about ways to output to different sorts of documents. SPSS talks about variables. A lot of R resources are still talking about variables, but they call them vectors, which I think reflects more of the math and computer science background of folks developing R. SPSS and most resources that I've seen talk about nominal and ordinal variables, your two forms of categorical variables. In R, they're called factors and ordered factors. So you'll see a lot of sometimes error messages that talk about factors or this analysis requires a factor. We have to make sure that our nominal and ordinal variables are defined as factors. In SPSS, SPSS calls numeric variables scale variables. In R, they're simply called numeric or integer. The only difference between the two is that an integer doesn't have a decimal. They both can be used for the same thing, but however, there are sometimes some conflicts between the terminology that we'll talk about later. So those are some of the main terminology differences that we'll be looking at. As far as differences in interface, one of the main things that it took me a while to adapt to using R was that there is no data editing window in R. In SPSS, I'm sure you're all familiar with the data editing, with the data window, where you can directly enter data, where you can make changes, go in and make changes to your data. In R, there is no editing window, and I think this is a conscious choice. I think that there's other software that does the same. The reason being is that all you really need to enter data is some sort of spreadsheet, whether that is Excel, Sheets, Open Office, whatever you're using. It's just it's unnecessary. R is assuming that you're going to use another program to edit data, so it doesn't waste its time creating that editing window. Viewing your data in R is possible, but there are also some limitations in terms of how much you can see and how effective R is in viewing data. In general, using R, you would be also using a spreadsheet program to manage your data. Other aspects, if you're making changes in R, for example, if you're creating new variables, the new data has to be explicitly saved. R is not going to prompt you and say, "Hey, do you want to save these data?" It's going to assume that you've got code and you can redo this at any time, and you don't need to save those changes. So R won't ask you questions like, "Are you interested in closing your syntax window? Are you interested in closing this?" It's just going. I'm sorry. Are you interested in closing your output window? Are you interested in saving your data? It's just going to assume that you don't want to do that. And, another piece here that's different is that within R, many complex analyses. And we can talk about some of the types of analyses that people might be specifically interested in. Many of these require external packages. What packages are they're user contributed. Functions that add utility to R. This you might be familiar with in SPSS. Perhaps the most popular user contributed add-in is what's called the process macro. And there's also some dialogue windows that go with that. That's one popular add-in in SPSS. There aren't a lot of others. However, with R really relies on these contributed packages. There's over 20,000 contributed packages covering all kinds of topics from all kinds of fields. There are packages for complex forms of multiple regression. There are packages for latent variable modeling. There are packages for dealing with missing data. All kinds of different pieces. That's something more for a more advanced course. But if you do have questions about specific analyses, please do post them in the on the Slack channel so that I can give you some additional information about where to find things. All right, we'll start off talking about R versus RStudio. This is a distinction that it's important to make. R itself is the programming language. You can use the R programming language as a standalone program. However, as we'll see, and we'll take a tour of both in a second, having a nice interface is not really a priority for R developers. So as we'll see. RStudio is a program that is a graphical user interface that came along to make R easier to use. It's got a lot of functionality that just smooths things over, that helps you. It has little helper functions. It has things in different windows so you can see everything all at once. It makes R easier, and it's very much, I think, the most commonly used interface for working with R. But within RStudio, it is a graphical interface, but don't expect a lot of pull-down analyses like SPSS. The menu structure is focused on saving files and things of that nature. You cannot pull up different analyses to run. One of the reasons for that is that R probably has at its full functionality at least 70 or 80 times the different procedures that SPSS can offer. So those pull down menus would be really overwhelming. One important piece here, and I hope everybody has everything installed already. And if you're having installation, if you still have installation problems, please do let me know during the break or after class today, and I can work with you on that. You need to have R installed prior to using RStudio. So R is the program itself, R is the engine that makes it run, and then RStudio makes it easier to use. So let me change my screen share and we can take a look at both programs. And I'll bring up R. And I'll change the screen share. And let me share that screen with R. Okay, so here is R. And this is what R looks like. If you open just R, it's going to look like this, and you will see, as I mentioned, the interface is not particularly fantastic. The interface is a little bit, it's honestly a little bit scary to first-time users. Now, I should back up a little bit and talk a little bit about the R programming language. R was developed is a programming language, but it was developed primarily for statistical applications. There are other uses of the programming language, much as you'll see with any programming language, it could be adapted to other pieces. But it was released in 1995. It was actually based off commercial software called S. The big difference here is that R is free and it's open source. It's regularly updated by a team of volunteers. A very large team. It's really and it got a lot of people who are contributing to it. If you haven't downloaded R yet, the R download link is here. You'd want to download this and simply download the base package. It's a little bit different on the Mac interface. I don't have great instructions for the Mac interface because I don't have access to a Macintosh. So what we'll do is take a look at what the R interface looks like. Here's the R interface. It starts off with all of these words. It brings up a single window. This single window is what's commonly called the console. This is where you can run analyses. Where you see the typing cursor, I can type things here. I can type code to run analyses. It's also where you get the output for your analyses. However, this one window is a little bit challenging because there's a lot of other stuff that's happening behind the scenes with R. You might have certain data sets open that you can't really see. They're just in what's called the R environment, which isn't visible. So this is what we get when we open up R. And when we open R, if you get this exclusively, you've opened R rather than RStudio. So let me close R and take you to RStudio, which is a far better interface. Let me stop that share. So I'm just going to start up RStudio and then I will share that just to give you a little bit of a tour of what's in here. Okay, so here is RStudio. Just bring that up so that I can see it. In RStudio, it looks the same at first. You see on the left-hand side, let me just verify again that I'm screen sharing. You see on the left-hand side that same console window from R. What I like to do is I like to click this button here to open this up. What this does is it splits this left side into two windows. The window on top, this is where we can write and save code, which is really the preferred way to work in R. You can write code down below in the console window, but it's not saved. If you're writing code up in a in a code or a syntax window, if you prefer that language, you can save things. You can have them to rerun. Very, very useful. It's very similar to what you would do for those of you who are familiar with SPSS syntax when you write code in that way or you paste code in that way and save it. So that's the upper left-hand window. This is where we're going to write our code and save our code. Down below, we have the console. This is where we're going to see the results of our different analyses. We're going to see what we would call the output in SPSS. And that's going to be down here in the console window. We can modify the size of these windows depending on what we're doing to give us more or less control, more or less space to work. Then over on the right-hand side, we have what's called the environment window. Or we have, well, it's got the environment, but it's got a bunch of things actually. The environment window here is where it will tell you what data files are available to be analyzed. We don't have any data open right now, but once we do, we'll see how this pops up in the environment window. This environment window also has some nice helper tools to allow us to import data from various forms. And then it has a handful of other pieces that aren't all that important for our course today. And then finally, down below in the lower right-hand corner, we have another kind of multi-purpose window. This is where you will see the graphical output if we're running doing data visualizations. This is also where we'll start to deal with adding what are called packages. There's a handful of very useful packages that we'll be working with. And again, I want to remind folks when we get to packages, if you do have specific analyses that you're interested in, please do let me know, and I can probably direct you to useful packages. So what I like about RStudio is it gives us just a lot more functionality. It gives us we're able to see a lot more of what's going on. There's a few other helpful things along the way that I'll show you, but that's kind of our tour of the two different programs. I generally do all my work in RStudio. I generally don't open R unless I'm demonstrating it for someone as we're doing here. So let me go back to my PowerPoint slides, and we will jump in. There we go. All right, so with all of the PowerPoint slides, I've tried to give screenshots of the things that I go over live, just so that you have something to refer back to. I know it's hard to remember everything, so I want to give it to you in two different forms. Again, we looked at the R user interface. All that is somewhere where we can write code and read output. It's one of many different screens that RStudio offers. RStudio, we talked about how R is a integrated development environment for RStudio is an integrated development environment for R. I like to think it makes R tasks easier. Lots of little helpful things that we'll learn along the way that just make it easier to do work. I do want to mention that with RStudio, there are two different versions. There's the free version, and then there's what's called, I think it's either the enterprise or the professional version. I've never had a need for anything but the free version. The enterprise version or the professional version, they changed the name a couple of times, so I'm not sure what it's landed on at this point. That is more for organizations who want to have lots of people working on servers. So that's what we piece. Also, I want to note, I know people are posting comments in the posting comments in the chat. I'll try to get to those during breaks, rather than to try to do it in real time. So again, get the free version of R. And then the other piece that I wanted to remind everyone of, I've said it a couple times, we want to download and install R first, and then RStudio. We had a little tour of RStudio, and just to remind you what we saw there, we've got our 4 different windows. Top left is the code editor, bottom left is the R window or the R console. Top right was the environment, bottom right was where we downloaded packages. And here's what it looked like. And as I said, I'd like to go through and show every step that I went through, just so that you have a record of it. Again, just to review, upper left-hand corner, that's where we're going to type our code. That would be like an SPSS syntax window. Similarly, it will create, you can save files. These will have an extension of .r rather than .sps for the syntax. Down below this window, we're primarily just going to use it to see what the output of our analyses are. We cannot save the output directly or in a way that's manageable. It does have to be copy and pasted if we want to save it. Again, when you learn about things like R markup in more advanced classes, you can see learn ways where you can directly insert that into various files. Up to the in the right, we have the environment and a few other windows. It just basically tells you what materials are available to you, what data files are open. One of the really frustrating things I found when I first started using R, before I used RStudio, is I never knew what was open because there was no data window that I could go to. And then in the lower right-hand side, we saw the multi-purpose window where we view and export graphs, add packages. We can look at files. There's help menus, lots of different pieces down there. All right, now we can get into some of the basics of code in R. R is a coding language. It focuses specifically on code. Most R code follows the same basic structure. You'll have the name of a command, and this command will generally be simple. It'll be something like mean or SD for standard deviation. Pretty straightforward in terms of the naming in many cases. I don't want to say in all cases, in many cases. The basic structure is that we're going to issue a command, and then in parentheses, I'm not in parentheses, yes, in parentheses, we're going to have the name of the data file that we're using, the $, and then the name of the variable within the data file. Now, there's many structures for doing this, and one of the things I want to caution folks about is that you'll probably see examples using R that use a different structure, that use a different format. That's really just a nod to how many very different things you can do in R and how many different ways there are to do the same thing, which is really great, but can be very confusing when you're learning new things. So keep in mind, if you see things that are expressed differently, there's lots of ways to do the same thing. I try to use the same consistent structure so that there's less confusion. So that we'll have a name of our data file, a $, and the name of our variable. I'll show you in a little bit why that's a nice strategy. If my data file was called example and the variable in that example was called time, if I wanted to obtain a mean value, I would simply type mean example $, time. For those of you who are familiar with SPSS syntax, you'll probably find that R code is a lot simpler. It's a lot more straightforward. SPSS syntax can be long and has lots of different options, whereas R is a little bit more direct. And again, as I mentioned, there's lots of correct ways to write the same R code. So don't be worried if you see things done in a different way. As long as you're getting to the same endpoint, that's all that really matters. All right, code structure. Oops. or some important rules, I should say. Like SPSS, our variable names can't start with numbers. They can't include symbols or spaces. But unlike SPSS, and perhaps one of the most important differences is that our code is case sensitive. What that means is that capital R and lowercase r are two completely different things. If you spell something MEAN, all lowercase, that's recognized as a command. If you capitalize the M in the mean, it's not recognized as a command. So the upper and lowercase are like they're completely different things. In SPSS, it doesn't matter if it's upper or lowercase, but it does in R. So R is case sensitive, and this is probably one of the biggest challenges in working with R. But definitely something to have in the front of your mind if you're getting error messages and things of the like. R saves all of the code you run in what's called its workspace. It doesn't save the output. It will ask you if you want to save your workspace at the end of a session. And I would recommend not doing so because those workspaces get really big. If you do a lot of statistical analyses, you can have a gigantic file with thousands and thousands and thousands of lines of code and really no context there. So I would recommend when it asks you if you want to save your workspace, say no. What we want to save is the code that we've used and the code that we've run our analyses with, because that's where we're going to that's what's going to be the most use to us, because we can always rerun that code to get our analyses again. Other pieces to talk about. Oops. All right. That ends the first section on some of the basics. Now we'll get into actually using R to do a few tasks. That's why we're all here. We're going to talk about importing data. And I'll talk about importing data. Oh, yes, I've got a question from Brandy. No? Okay, I'll go on. So.
Oh, I'm sorry. Oh,
that's all
right. Sorry. Can you explain the difference? You said you don't want to save the workspace, but you want to save the output. Is there different options to do the different save?
You want to save the
or I'm sorry, the code.
The code, yeah. We'll talk about how to save the code. There's just a file save,
Okay.
a file save option like in SPSS.
Okay, thank you.
Of course. All right, importing data. How do we get data into R? That's the first step. And honestly, it's unnecessarily challenging at first, but there are some ways that we can make it easier. With R, we'll start off with importing what are called CSV files, and then of course we'll get to later how we import SPSS files, and you can get files from other programs. In short, R can pretty much handle everything. It can handle any sort of data. It can bring in just about any sort of data file. So opening a CSV file, this would generally be a file on your computer, and this is the most common format for data in R, comma separated values. The reason why it's such a common format is that pretty much any spreadsheet, whether we're talking Excel or Open Office or Sheets or whatever you're using, any spreadsheet can save to this format. It's very much a universal type format. In terms of commands, we're going to be using the command read.csv. And again, we see with each of these commands or functions that there'll be parentheses, and the parentheses simply indicate there that there's something that you're going to need to enter in the parentheses. One of the challenging parts here is that you have to provide the file path. Back when I started working with computers, everybody had to know everything about file paths, but we've made things a lot easier. Now you can just double click on a file to open it up. You don't really have to know where that is. So this is something that is going to be specific to your computer, to where your materials are. I have a data set that's called climate. It just measures various aspects of attitudes toward climate and some personality measures. I'm just using it as an example here, and we'll practice opening that up. The data set called climate, if I wanted to open that, I would issue the command read.csv, and I'll talk about the other stuff on the left in a second. And then I say file equals, and then the directory where this is. And this will look different if you're on a Windows machine or a Mac machine. I'll also show you in RStudio if you're having problems doing this. If you're having problems getting the exact directory, which can be challenging if you're not familiar with using directories, that RStudio has some nice helper options there. Now I've got my file in a drive called G, my drive. I've got everything on my Google Drive. My directory is R for SPSS users, and the file itself is called climate.csv. Now this part over on the left here, I've written the word climate, and then I have the less than sign and a dash. That less than sign and a dash is, you can think of it at like an equal sign. In fact, you could use the equal sign here. Just this is more common, really what you'll see in our code. This is what's called an assignment. What that does is it's going to say, okay, make me something called climate that's going to have the data that's in this file that I've specified. This is what is sometimes called an object. R works with lots of different types of objects, but if you write this to your if you write this to an object, then it's directly accessible in R, and it will show up, and we'll see that we can write code that accesses the variable called climate. Now I've got mine matching climate.csv and climate here. I could call the stuff to the left anything I wanted. I often just use XX or YY as the name of the data file, just as a short reference. You can call data files whatever you want. It's not necessarily linked to what the actual name of the data file is, and that's a little different than an SPSS. One shortcut that we'll see here, we can open using the RStudio import function, and I'll just give you we'll go over to RStudio, and we'll take a look at how we can do that. And you'll again have the opportunity to practice these things. So if don't feel like you have to do everything as I'm doing it. So now I'm sharing RStudio. Let me just make sure that's shared. There we go. In RStudio, we can type the code. We can type this code that we have here, read CSV, and so on, and that will bring in our data. Or, oops, or we could use this import dataset function. If we choose import dataset, this is I think one of the most useful, most helpful things in R Studio to get you going. It gives us a number of options. We're just going to go on to open from what's called text. That's what R calls CSV and various other formats. So I'm going to choose from text. And you'll see that R now brings up a window where I can navigate to wherever my file is. And this is probably a more familiar way than writing out the file name. So I'm going to go to my directory, which is R for SPSS users. And I'm going to go to climate.csv and just click on it. And now what R will do is it'll begin to import the data. And it will give you a variety of different pieces. It'll ask you if there's headings. And yes, and this is very much like importing data from an Excel file or other files in SPSS. It'll ask how things are separated. In general, R will detect all of this automatically, so you don't need to worry about most of these. This option strings as factors. I like to have that clicked in order to facilitate a few things. I'll make things easier, and we'll talk about why we do that in a little bit. But for now, I would just say, just be sure to click it. And then we simply click import. And when we click import, we'll see that R brings up a window that shows us our data. We can we can scroll through here and see various variables, see all the cases we have. So that's one nice piece here with RStudio is it does bring this up. However, we cannot edit in this window. We cannot make changes in this window itself. If you want to make changes to data, you would probably want to do that in a spreadsheet. Again, R and several other programs, I think M plus, other statistical packages, have all kind of made the decision that they're not going to have data editing functions because there's so many other options for it. Another thing I want to point out here is now that I've opened my data, if we look in the environment window, we see something that's called climate. That is the name of my data. That's the my data file, and that's R telling me, hey, you've got data over here, and this is the data that is available for analysis. This is what you've got that's open. This is very much like having an open data window in SPSS. Some other nice things here is if you click the little arrow, or it looks like a play button actually. If you click that, you can go through and R will tell you the names of your variables and what type of variable they are, if they're integers, numbers, or what are called factors. Now, with these factors, these are what we would call nominal or ordinal variables in SPSS. One difference between R and SPSS is that R represents all of these categories with their name. So you see the men are listed as men. Years of high school are listed as how many years. This isn't like SPSS where you have the viewer where it's you can show the value labels. This is actually entered into the data file as these words. So R is using words for factors or for nominal and ordinal variables, and it's using numbers for regular variables, whereas SPSS is using numbers for everything and then putting labels on those numbers. So that's one difference here. That's one thing that it takes a little getting used to. But not terribly different. Okay, just wanted to show you how we could do that, and we'll have an opportunity to play with this and to do hands-on stuff in a short little bit. But let me go back to my PowerPoint slides. Okay, so we talked about how to open a CSV file, and then again, I just included the instructions here so that you have a guide if you need to go back and figure out how to do that. How to do that again? We'll talk about importing from SPSS in a little bit. That requires a little bit more stuff. Again, just showing how we navigated to the file, how we chose the import option, and now I guess we can have time for our first hands-on exercise. In the Google Drive and also in the chat, I placed a link to the drive. There's a file called hands-on exercises that we'll be using over the next 2 days. What I'd like folks to do is to take a little bit of time to complete problem 1 and just to talk a little bit about the hands-on exercises. I tried to design these to make sure that everyone can complete the tasks that we go over. I want to have multiple sessions to ensure that everyone's progressing, everyone's do this. If you are listening to this if you're watching this on a recording, it's useful to stop and do these things as you go. This first session is focused only on data import. This will go smoothly for some folks, might be a little challenging for others, so I want to give a little bit of extra time. Also, one of the challenges in teaching a class like this is that everybody's computer is set up differently. Everyone's got things in different directories. Everyone's got things in different places. So that can be something that leads to some challenges. I will try to have a fair amount of time available for questions during the hands-on session. I'll be here. I'll be here for questions if you get stuck on something. we can try to work through that. I do have to draw a balance though between getting everyone between dealing with everybody's issues and actually getting through the course material. So if I don't get to a question during during one of these hands-on sessions, I will definitely make a note of it and get to it at the break or after the class today. I don't want anybody to be terminally stuck, but I do want to make sure that the class progresses. So that's kind of a balance. Good. If you don't have time to get to your if you don't have time for me to get to your questions, if you post screenshots onto the Slack onto Slack where we have our course discussion, I will definitely get to them during the break or today. That's probably the most effective way to let me see what's going on with your computer is by posting screenshots. Okay, let me just show everyone the hands-on materials, and then I'll let folks try to work on things for a little bit. I just need to bring those up. Okay, so here are the hands-on exercises, and again, I posted the link to these in the chat. Those also came through on several on several emails, I think. All we're doing for this first exercise is importing the climate.csv file. I'd like people to try to import it using both code and then using the RStudio interface. And after importing that, try to save your code. All you need to do is choose File, Save, and then it works just like saving things in SPSS. So I'd like people to try that to see where we're at. I'll try to give this about 10 or 15 minutes, and some people will get done with it a lot faster than others. Some people may need all the time. Some people may need less time. That's just kind of how these things will go. So you might find yourself with a little extra time, a little extra break if you get through things smoothly. All right, I'll stop talking now, and I'll be here for questions as people are working on things, and I'll take a look at what's in the chat and see if there's anything I can address. All right, and I've got a few questions in the chat that I'm that I'll work through here. Okay, I had one question about the little assignment, the less than and the the less than and the dash, where the command saves data to, and whether it's still there, when you go back to RStudio later on. This actually does not save it. It leaves it open. It opens your data for the specific session that you're working in, but it does not write to your machine in any way, because that CSV file or whatever you've opened is already on your machine. So that's just bringing it in for use in R. Another question: is there a specific way data need to be prepped to feed into R from the CSV file? In general, the best strategy is to use what's called wide format, which is what we see in SPSS, where each person has their own row and each variable has their own column. That general format works for most analyses in R. For some reason, when you get to some more complex analyses, and this is the same as SPSS, data might need to be restructured differently. But generally, for most things that you're working on, that would be sufficient. Okay, the save button is grayed out after importing the climate CSV file. Again, that's because there's nothing to save yet. The save button is going to be saving your code itself. If you haven't written any code, there's going to be nothing to save in that in that window. Yes, when you save something, for example, when you save your code, that is saved permanently. Where it's saved, though, is really computer dependent. So you would have to kind of scroll through and figure out where things are on your specific machine. That's something that's really challenging in a class like this, because everybody's machine is pointing toward different places by default. I think as a default on the Macintosh, it goes to the download folder. As a default on SPSS, it probably goes to your users directory. I'm sorry, in Windows, just the users directory. Is the Haven package. We'll get to the Haven package in a little bit when we talk about packages. Okay. Running the code and got this error message. Climate. Yeah, this one error message from Denise. This is I think specific to your machine, but I can probably work with you individually on that during a break. Oh yes, and saving saving after the import. I should have been more specific there. I was referring to saving saving the code itself. Right, saving the code. Saving the code, you can choose the little the little save icon that looks like an old style floppy or an old style disk, or you can choose File, Save, and again that's from the upper left hand window. That's only for saving the code. Oh, okay. I think I mentioned this before, but I've got another question. Where does the assignment command save your data? Nothing is being saved in R. When you're importing it, it's active for use, but nothing is saved in R. It's not saved in any specific directory. You would again have to access the data. You would have to open it up again in your next session. Very much like with SPSS. With SPSS, you've got to open up your data file for each session. Same thing with R. It's just that it's done a little bit different.